for potassium dichromate. The potassium dichromate is actually K2CR2O7, which technically breaks into 2K plus and CR2O7 2 minus. So this CR2O7 is the same we used in the last question. It's dissolved in a water of 250 mils, so that the volume of the water, so that means we have 1.50 grams, and it was put it into 250 centimeter cubed volume. And then once it was, just make it bigger there. Once it was dissolved, they took 25 centimeter portion of that solution, and it was added to potassium iodide and dilute sulfuric acid. So it's a very similar reaction to what we just did in the previous case. So we have CR2O7 plus, let me write down the full reaction here so it'll be easy for you to look at it later on. So K2CR2O7 plus, it was reacted with Ki, potassium iodide, plus sulfuric acid, H2SO4, and it makes, let me just double check on that. So that actually makes CR2SO4 3 plus water plus iodine. Obviously it's going to be water here, plus it's going to be iodine and K2SO4. If I balance it, it's, you have 6 there. Now those reactions, you want to make sure you know how to balance those. Actually, I already balanced those on a piece of paper, so that's why I know how the 6 and 7 came in. And then you have 7, 3, 4 there. So you have 7 there, 3 there, and 4 there. So the second part of the question, it says when we reacted 25 centimeter cubed portion of the solution with the Ki and dilute sulfuric acid, we made iodine. So the iodine is I2 that was being made here, and that iodine was actually titrated again with another chemical. So iodine is again titrated with sodium thiosulfate, which is Na2StO3, Na2S2O3, and when it titrated with that, it makes Na2S4O6 plus NaI. And if we balance that, we need 2 there, and the rest should be good. And they also said they were titrated with 19.20 centimeter cubed of Na2StO3, and the molarity of that compound was 0.108 moles over dm cubed. Now one trick here is the concentration which is 0.108, is given in moles over dm cubed, and the volume is given in centimeter cubed. So we need to make sure we have the same volume, the same units, in order to calculate the moles of Na2StO3. Once we calculate the moles of Na2S3, we can calculate the moles of I2, because that's 2-to-1 ratio. And once we have the moles of I2, we can calculate the moles of K2CR2O7. So it's a little lengthy process, but see if that makes sense. So write down here, so open up the page here. So we have 0.108 moles over dm cubed. Now 1 decimeter is 10 centimeters. So we use that equality here to convert that. So since the decimeter is cubed in the concentration, we can cube this equality there. And then we can multiply that with volume, which is 19.20 centimeter cubed. Alright, that will give us the moles for Na2S3, and for every 2 moles of Na2S3 S2O3, we have 1 mole of I2. So here, moles of Na2 cancels out with the moles, so watch for the color combinations here. Decimeter cubes cancels out with decimeter cubed. Then centimeter cancels out with centimeter. At the end, we are left out with moles of I2. Alright, so let me do the calculations there. It's going to be 0.108 times 19.20. Alright, and then divide by 10 cubed. Make sure you do the 10 cubed there. Okay, and then divide by 2 again. So that comes out to be 0.00103. 0.00104. Now, these are the I2 that was produced in the previous reaction. So that means the moles of I2 in the first reaction we wrote down was 0.00104. Now from here we can calculate the moles of K2CR2O7, considering we know the mole ratio of I2 and K2CR2O7. So that's going to be 0.00104 moles of I2 times 1 mole of K2CR2O7 divided by 3 moles of I2. Now once we have the moles of K2CR2O7, we can get the mass of that using the molar mass of K2CR2, and the molar mass of K2CR2O7 is 294.19. So that's going to be times 294.19 grams over 1 mole of K2CR2O7 And then again, watch for the color combinations. Moles of I2 cancels out here, and then moles of K2CR2 cancels out here. And the final mass of K2CR207, that's going to be 0.00104 times 294.19, and divide that by 3. So that comes out to be 0.102. Oh, I forgot a step there. Sorry about that. The step I forgot here. We have a 25 centimeters cubed that was taken from the portion of 250 mils. So that means the total amount of K2CR2 in the 250 mils of solution was 10 times than what you have in only 25 centimeter cubed portion of the solution. So whatever we get here, 25.102 grams of K2CR207, that's in 25, just write that down here, that's in 25 centimeters cubed. But we need to get what we have in the 250 cube, so we just multiply that by 250 because the total solution was 250. So centimeters cubes cancels out here, and then that's going to be 1.02 after you multiply. So the total amount of potassium dichromate you have in a solution of 250 centimeter cube is 1.02. Now, at the end, we need to get the percentage purity, and the percentage purity is going to be the amount of potassium dichromate, which is 1.02, divided by 1.500 grams times 100. So that comes out to be 67.8%. So let me know if that makes sense.